Okay, everybody. What we're going to do here is we're going to walk through how to do Lab 1, and it's going to apply pretty much to all the labs on how to do this. So what we're going to do is I'm going to go ahead and start sharing the screen so that everybody can see what I'm looking at. Okay, hopefully we do see the screen. Now, the first thing that we need to do is we need to get into, the general chemistry.
Mhm.
And we're going to go down to content and assignments, and it makes you go through several clicks to get on down there. But we got test one material, and that's where you're going to find the lab. Now there's a lab in every chapter. Okay, so here's lab one right here down on the bottom, and it has two pieces on it. Um, Let me zoom in a little bit here. It has the lab itself as a printout, and it says 151 underlined 01. That means it's for Chem 151, and it's lab number 1. All right. And then there's how to write a lab report, which is helpful to read ahead of time, but it's okay. I'm gonna show you how to do this. And we have some examples of good labs below it. All right, now the procedure starts on page 7, but let's go ahead and take a look at it from the beginning because we've got to look through it, not just the procedure, but we got to take a look and decide what it is that we need to do here. Okay,
Mhm.
so this is experiment 1, and this is pretty classical for general chemistry 1 and even some of the other chemistries. Is the very first thing you do is you do a measurements lab. Now, why would we do a measurements lab? Because we measure things in the laboratory. That's why. Okay. Now we go through sig figs here, and that's on page 1. And then we got some examples of sig figs. And right now I'm showing you the general layout and combining calculations. How do you do it? And this is stuff, by the way, with the rules for significant figures. There's videos on it, and it has a way of making itself onto quizzes and tests. All right. It's one of your sources. The difference between this and say doing a homework is this is one really big problem as opposed to, do number 8, do number 9, do number 10, so forth with the homeworks, okay? So we have significant figures, and then we have the difference between accuracy and precision down here. And then we have something about the metric system. It's useful to memorize that. And converting between temperatures, and go through all of this. And the labs are going to be like this. They're going to be page after page of introduction stuff. Okay, how to read a graduated cylinder. Okay,
Mhm.
and we get all the way down. We keep going. We keep going, and finally we get to the procedure. Finally, we get to the procedure. Now, the procedure, it's important to follow the directions. Okay, and then um, using the information above, it will help you do the lab. Okay, so let's go ahead and pretend like we're doing this lab, and I have a graphical tablet for this, and I'm going to open it up, and we have the ruler. This is what a lab notebook would look like, and we're going to measure the length and width of the book in inches and round to 1 decimal place. So what does that mean? So I'm going to look down here, and we'll go ahead and open up my whiteboard, and we'll have the previous stuff I've been working on. There it goes. And let me just start with a blank. Now, before you start on the problems though, we need to go ahead and make up a cover page. Why not? And what's the cover page going to look like? Well, it's going to have an objective. This is the cover page. And what's the objective? Well, the objective is usually found in the first sentence two of the lab, but this one is going to be, we are making a series of measurements. That's exactly what we're doing in this lab. We're making a series of measurements. And I'm not much of a typer here. Making a series of measurements with proper significant figures. Okay, that's our objective. And for our objective, we want to keep things short and sweet, but it should be representative of what it is we're trying to accomplish. Now, what's the next thing that comes up? Well, we have the objective, and then we have materials and equipment. Materials. Yeah. Materials and equipment. Now, this is not, we don't have any equipment ourselves, okay? But that's what the purpose of the photographs are. And so what we would put down here is we would say we would have a ruler. We do. We just took a look on page 7. We had a ruler. We have graduated cylinders. Let's see, cylinder and a burette. These are the things that we would need if we were actually doing it in lab. And then finally we have antifreeze, which is for the very last part. And there you go. Okay, so this is the materials and equipment. And once again, we want to keep this short and sweet because this is the cover page. We're not looking for writing a book or rewriting the lab. Okay, materials and equipment, ruler, graduated cylinder, burette, antifreeze. If you see me misspell something, just let me know because I'm not the best speller in the world. And then we have safety. And you may say to yourself, what in the world do we need to do as far as safety goes? Well, remember, this is a simulation of or a practice of if we were doing an actual lab, and you would say, well, one thing I always need is goggles, and I believe that's with 1 O. Yeah, we need goggles. I was about to put down Google as in 2 O's. Goggles, and in this case, that would be pretty much what you need, and perhaps a lab, long proper attire. We'll just leave it at that. In other words, you want, if you're actually doing this, you would want to have, a shirt, um, long pants. Okay. Proper attire. Is that 1 T or 2 T's for attire? It's getting late.
2.
It is 2, so I spelled it right. Good. And let's go ahead and see if we can move this over just a hair, just not worry about it. Okay, and then we have materials, safety, and then we have um, the conclusion.
Oh, I'm sorry. Actually, it is 1 T.
It is 1 T. Okay, thank you. All right. I don't know about that. It doesn't look right.
I know it doesn't look right.
English is that way.
Or maybe
Hmm.
I think
Oh, attire means to put them on. 2 T's, I'm pretty sure, is attire,
okay.
dress, clothes. It is 2 T's. Okay, well, that's all right. This happens in the classroom too. And a conclusion answers the lab. What are you after? You're making a series of measurements, and your conclusion, once you do the lab, would be like the area of the book was found to be. And I'm just going to make up some numbers here. Was found to be. I think it's actually around 12,000 square millimeters squared. Okay. And then we would say then there's actually 3, and so the burette was most precise. And that's because you can read 2 decimal places. Was most precise. And finally, we say, now we're going to measure the density of antifreeze at the very end, so we need to know the density of the antifreeze, and I'm just making up these numbers, was found to be. let's say 1.21 grams per milliliter. Okay, that's a density with a percent difference. Percent difference. In other words, how far is it off from what we know what the antifreeze should be? Okay, so the density of the antifreeze, maybe it's 1.19, but we measured 1.21. This is the nature of experiments. Okay,
Mhm.
and then we say, you know, one source of error might have been an error. Let's go ahead and put that. Error might have been estimating between the lines. Okay, and now what you don't want to do for error is you don't want to say human nature. That's just saying you have no idea. When we say error, we want to come up with something that's a little bit reasonable. So we got conclusion, area of the book, the burette, the density, the antifreeze. Okay, and let me make sure that I'm pulling up everything here. And that's an example. That's not what I wanted. Here we go. And we got title, we got the date, we got the objectives, chemicals, equipment. Oh, waste disposal. Yep, we got to put waste disposal in there. Here we go. And that would go somewhere between safety and the conclusion. So we'll say waste disposal. Now, granted, you're not doing any actual waste because it's a paper lab, and so we return the antifreeze to its container. Okay, now ordinarily we don't return chemicals back to the original container because of what? What do you think?
Um, because it might
It might contaminate, you
yeah,
know,
it might
you
contain.
don't know what was in most of this stuff. So conclusion, there you go. And so I've hit all the objectives here. And we have the conclusion, we have waste disposal, we got safety. And the bottom line is we want to keep this short and sweet. Now this is page 1. This is my cover sheet. And of course the title would be whatever it is. What does it say? Let me see if I'll go ahead and find it here. It says measurements and significant figures. There we go. That you just get off the measurements and significant figure. Okay.
So it doesn't have to be as long as the ones in the example problems.
The example problems, they're really well written, but they are, as you probably noticed, they are a little wordy and they don't have to be that wordy in the example. I
Okay.
prefer short and sweet. If you need to add more stuff to add clarity, and that's okay. And significant figures. Here we go. Make sure significant. There we go. Significant figures and measurements. All right. I cleaned up my spelling here. And I believe measurements is with an A. Yeah, here we go. And where is it? Yep. All right. Now, we have our cover page.
Hmm.
We're done with the cover page. We need to start a new page, which is our observations and calculations. This would be page 2 and so forth. And so we're going to start with a blank canvas. Now all this has been preparatory. I mean, I found the procedure, but I got all these other things I need to do first. And this is page 2 and more. Okay, and these are going to be observations, observations, I believe that's spelled correctly, observations and calculations. There we go. Page 2 and more, observations and calculations. That's what we have here. So now we're going on to page 7, starting on page 7. And we say, part 1, is it part 1 or part, well, let's see, I need to go back to the lab. Here it is. And it says part A. Okay, so it's part A. And if you said part 1, it would be okay. But we're going to go ahead and call it part 1 or part A, the ruler. All right. And we go back to our lab. Where's our lab? Here it is. And it tells us measured the length and width of the lab book in inches. And it says round to 1 decimal place. Now to round to 1 decimal place, what would we do? What does it mean to be 1 decimal place? And so we'll draw on here. And let's say we had, and that's in centimeters. How many decimal places do we have? We have 2.
Mm-hmm.
If we want 1 decimal place, we're going to have to round that 8 up. And so that becomes 23.3 centimeters. Okay. And that's the 1 decimal. All right. Now we look at our actual lab though, and the measurement. Now I'm just giving examples here. And the actual measurement, well, let's take a look. And now, since it's to 1/10, if you not many people know how to read a English ruler. It goes halves. Can you see my arrow?
Yeah.
Okay, good. So it goes halves, quarters, eighth, 16th, and you can have more in there, 1/32. Okay, it's you got to know your fractions to be able to add, let's say, a 32nd to a half. Okay, but we don't want to do that. We want to go out 1 decimal place. And so what we will do is we say it's at least 11. I wonder if I can write on this. Nope. It's at least 11, and that's in inches.
Mm-hmm.
Okay, here's the 11 mark right there.
Yes.
And it looks like if you count the fringe, it's just a hair over 11. So we go back here and we say, and I'm going to go ahead and erase what I put here. All right. And here comes our measurement. And so we say, well, what do we decide? It's at least 11 centimeters. Okay, it's at least 11. But we need to go out 1 decimal place. And that's where we're going to estimate. And so we find our lab again. Now, this long line in the middle, that's 11.5. This line, the second biggest line here, is about 11.25, because you could go 11.25 or 11.3, 11.5, 11.8. You know, I'm rounding to 1 decimal place. Well, it is just over 11. So you could say it's either, I would say 11.1. Remember, we're trying to just imagine that this is divided up into 10 parts. So we say, you know what? It's 11 at least. I look at this fringe here and it's 11, let's call it 11.1. We're going to round. It's not 11.0. 11.0 would be right on the line. And so we go back and we say, okay, well, it's 11.1 and it's in inches. It's very important to include units. Always include units. All right. The reason is you want to always include units is, well, this whole first section here has got you doing inches and centimeters and millimeters. Which one's which? Well, it's 11.1 inches. And we go back to our lab and we look at the next one. And now we're measuring the narrow side. So we had the height. Usually that's the tall one, or could say the width. It doesn't really matter. Now we have still we're in inches. And do you see what I mean, though? That we're still in inches. This is in the other direction because we're going to calculate an area. See, record with the correct or measured. We're going to do the area and we're going to convert. All right, so we look at this and we go, all right, well, it's at least 8. You agree?
Mm-hmm.
It's not 9. It's at least 8. It's not quite 8.5. Because 8.5 would be right here with this long number here. And remember, we're trying to go out 1 decimal. Now, if you know how to read English rulers, you can go out 2, 3 decimal places easy. But we're trying to keep it simple here. So we go 8, not quite 5, not quite. It's I would say it's over 4. Some will say, oh, what do you think? Like 8.4 maybe. So it's 8.4 inches in the other direction. So I'm going to go ahead and write that down in the other direction. Okay. Now remember, we're still, we want to keep this. We're following the directions, which means we have 1 decimal place. We rounded to 1. Now, if you said 8.5, that's not necessarily all that wrong because the last digit is always estimated. So if you said 8.3, okay. If you said 11.0, okay. If you said 11.2, okay. But if you say 11.9, it's obviously wrong. And so that brings up this point here. The last digit of any measurement is estimated, which means that, I'm going to have to move this over a little bit, is estimated, which means you may say a different number than I say. There's really no right or wrong in the sense of the last digit. But if you look at the ruler, it's definitely not 8.5. It's definitely, and here would be 8.3 right here, because that would be 0.25. I mean, that's a quarter, that's a half, that's 3/4. That would be 8.3. I think it's between 8.3 and 8.5, which makes it 8.4. Do you see that?
Mm-hmm.
Okay, and so we recorded it. Now, we need to convert our inches to millimeters, and the relationship we have is it's 2.54 centimeters to an inch and 10 millimeters to a centimeter. We want to convert our measured inches and we're going to get a number. Okay. And so the conversion is we take our inches and we're going to set up, and I've got plenty of examples in the videos, but we'll go through this. An inch is, let's see, let me erase that. Here's the conversion. I'm just rewriting it up here.
Mm-hmm.
Is 2.54 centimeters to an inch. Okay, that's the conversion between the two. And then you have to convert from centimeters to inches. And it turns out there's from centimeters to millimeters, there's 10 millimeters for every centimeter. Okay. And so we say 10 millimeters, and that's a 10 for every 1 centimeter. Now, we always set up things so that we know our this is why we use units, is so that we can cancel units and what's left over. Millimeters.
Mm-hmm.
Millimeters. So I find my calculator. What do I do with that thing? Grab my calculator here, and it looks like that is, and of course, how many inches do we have? We'll go ahead and write it down here now. That's our conversion. So let's do the calculation. So we say inches times 2.54 centimeters per inch, and then we're going to say 10 millimeters for every 1 centimeter. We put this in our calculator as soon as I locate it. There it is, found it. All right, so we say Oh, what do we got here? We've got 11.1, and then it's times 2.54. That should be 2.54. Okay. Because I just went straight to millimeters by doing that. Okay. So 2.54 centimeters per inch. So we say times 25.4. And I get 281.94. Which, if we use significant figures, we go by the least number of significant figures, which is why we had that first 6 pages was deciding what's significant. But what we can do here is we say, this is 11.1. That is, and we'll change colors here. This is 3 significant figures. This is defined, although it looks like it has, and same thing here. This is defined. So our answer should be 3 significant figures. So we go 1, 2, 3 to the 1, 281, that's 3. Least number of significant figures. We look one more over at that 9, and we say that is equal to 282 millimeters. Okay?
Mm-hmm.
And I'm going to erase the conversion here. I just put it down there for illustration purposes, and we can do the same thing for the other one. Let's go ahead and redraw this down here. That should be 282. There it is. And we do the same thing here. 2.54 centimeters per inch, and then 10 millimeters for every centimeter. And we put that in our calculator. And we go 8.4 times 2.54 times 10. And I get 213.36. And I look here, let me change colors here. This is 2 significant figures, and this, of course, is defined. That is also defined. In other words, everybody should know there's 10 millimeters to a centimeter. That's what makes something defined. Something you measure has significant figures. So we have 2 there. So our answer should be 2, because that's what we have here is 2 over here. And we say that is equal, so we go 1, 2, look one more over. That is 210 millimeters. And this is 3SF up here. This is 2SF down here. Okay, so we just went through and converted following the directions. Once we made our measurement, we converted it to millimeters, just like it asks us to do here. See, convert the inches to millimeter. And now we've made the measure the length and the width in millimeters directly. And so we're given the centimeter side. Now millimeters is centimeters times 10.
Mm-hmm.
It's right here, 10 millimeters for every 1 centimeter. So now we look at this and we say, well, that's 27. It's at least 27 centimeters. It's not quite 28. So I'm going to say 27.9 centimeters, 27.9 centimeters. And so we'll measure, and I'm going to annotate it and say, measure in millimeters directly. And we get, what did we decide that was? 27 point, what would that be? 27.9. And we have to estimate in between the digits. Now, in this case, we want to go out 2 decimal places, and I do believe it says that over here. Yep. The major importance is the predicate of the second decimal place. You always go out 1 more digit than the smallest increment. So the smallest increment is point whatever centimeters. Well, we can go out 2 because it's at least 27.9 right here.
Right.
but it's over it, but it's not quite 28. So we say 27.9, 27 point what, 98,
Mhm.
27.98. So we'll put that down there. Centimeters, and look at that. That's 4 significant figures. That's important. And then we're going to multiply times 10 millimeters per centimeter. Well, I can do the math in my head on that one. 279.8, and we need to round the 4 sig figs. And what do we have here? We already have 4 sig figs. 1, 2, 3, 4. This is 4. Okay. And so we say 279.8 millimeters, because the centimeters canceled, you're left with millimeters. All right. Now we can go ahead and do the next one, just like it says to do. It says measure them both. And now we can calculate, well, we're going to have the other one. So I got 21 point, what do you think that is in the other direction? That is 21 point what? We just
Um,
did the long direction. How about the short direction?
21 spot 6.
21.6, and you got to estimate in between the lines.
7.
21.67, okay. And so we have, make sure I'm on 21.67 centimeters in the other direction, 10 millimeters per centimeter. We got 4SF over here, so our answer is going to be 4SF because 10 millimeters to a centimeter is defined. And we have 216.7 millimeters. There you go. Now it says, what does it say to do next?
I'm sorry. Calculate the area of the lab book in square millimeters. Use the measured numbers from 2.
And 2 is where we converted.
Okay.
Yeah. All right. In square millimeter, use the numbers from 2. Do we really want to use 2, or should we be using 3? Oh, number 3. Well, how do these values compare? That's what it's asking. So let's not get ahead of ourselves. It says, how does this value compare to the converted value in number 1? How do they compare?
Um, well, the first one's larger.
Yeah, I'm trying to squeeze this on down here. Well, if you look at them, you definitely picked up more significant figures. That's one thing.
Hmm.
You had 3 significant figures, 2 significant figures, and down here, when you measure directly, you had 4SF for both ones. Okay, that's the kind of thing we're looking for. Now, is it bigger? Well, it looks like it's slightly bigger. Instead of being 2, let's round the 3. That would be 280. This is 282, so it's slightly bigger in the long direction. And then we look down here, and this should be 220 if we had 2 sig figs, so it's actually a little bit shorter. Let's see, measuring directly is actually a little bit bigger than the millimeters that we calculated. Okay, so exact opposite. So we write down, whoops, don't want to do that. This thing will let you drag stuff around when you don't want it to. And so we would say, a reasonable answer would be is it's 3SF versus 4SF. Okay, and there was some difference. Small difference. It's a small difference. And you can say, whether it's bigger or smaller, but, there was some small difference. And that's how you do that right there. Okay, so, that answers that question. And then finally, we need the area. And if we read the instructions, and sometimes they don't make a lot of sense. And we have number 4, calculate the area in the lab book. Okay, So that's all we're doing is we're taking the square millimeters from 2. Where's 2?
Hmm.
That would be where we converted inches to millimeters. And how do we get the area?
Length times width
Yeah,
times
you
2.
betcha. And so we say the final question is whoops, I didn't mean to do that. Let's see, where do we got here? Is that the pen? Yep, that's the pen. And so the last thing that section A says is what's the area? And so it's length times width, like you said. So it's helpful if you can go length times width, and then we say, well, the long side was what? It was, whoops, looks like I have to drag it on down here. It was 282, okay, 282 millimeters. And then that was times the short width. Remember, it's the inches conversion. That's from number 2. And that was, what was it? 210. So we have to use the 210. And so we come on down here and we say times 210 millimeters. And then that's something we can put in our calculator. We'll drag this over so it's on one line. And we say 282 times 210. And I get 59,220. 59,220. Go ahead and type it in. 59,220. But how many, and what's the units on this? What do you think?
Millimeters
Millimeters squared.
squared.
Yeah, because it's length times width gives you squared. If you had length times width times height, that would be a volume, which would be millimeters cubed. So a millimeter times a millimeter gives you millimeters squared. Whoops. Let me go ahead and get my caret back here. Millimeters squared. Now, do we have the correct number of sig figs? And the answer is, well, this right here is what? 3. That's 2. So our answer should have how many sig figs?
2.
2, because it's the least number of sig figs. And that would be 59,000. Because we would go 1, 2. We look one more over, and it will be 59,000. Now notice it is not 59. You have to keep the same size. Because 59 is a lot smaller than 59,000.
Mm-hmm.
Yeah, keep the same size. Okay, that's a common mistake. It's just a, so all right, well, I got 2, that's 59. No, it's not. You got to add extra zeros to show how big it is.
Mm-hmm.
Okay, so that's how you would do this part right here, would be part A. And we're going to do the same thing for all the other parts. So we got measure and volume. It says, you got 10 millimeter, 10 milliliter, 100 milliliter, 50 milliliter burette. Here they are, and they're labeled. All right. And shows you how to read them. Generally, you're only going to measure out to 1/10 on the graduated cylinders. Okay, so the 10 and the 100 only measure out the tenths. And so we would say, let's see, which one are we going to use? Record your measurements. Okay, so we have the 3. So this first one would be the 10 milliliter, even though it doesn't say, but it's the first one up. See? This one would be the next one up, which is the 100 mil, well, the graduated cylinder. Yep, 100 milliliter graduated cylinder. And this one goes 6, 6.2, 6.4, 6.6, 6.8, 7.0. It goes by 0.2s. So you got to take the division 6 by 7 and divide by, the 5 tick marks. This one down here, it's the same idea. except this time we're going 50 to 60. You got 10 tick marks. Is that a 60? Yeah, it is. It's a 60. So we got 10 tick marks. This is 1, 2, 3, 4, 5. And let's see, and that would be 50 point. You could technically you could read it out to 2 sig figs, but usually we just do 1 sig fig for that. Now we get down to the last one, that's the burette. Now burettes read from top to bottom.
Mhm.
So it goes 17, 18, 19, 20. You see how that goes like that way, whereas these guys go from bottom to top. Burette is for measuring how much you just added. And so what would we say this is? So we count down from the 17. 17 what? 17.5. And then we're going to estimate, that's at least 17.6. There's a 6 tick mark, and you always measure from the bottom of the curve. 17.6 right here. And then you got to estimate one more. I'd say that's 17.62. So the burette, you can easily read out the 2 decimal places. And so it asks a question after you've made these measurements, which is part 1. Part B, question 1. Where is it? Right here. And we want to record your measurements. And then you get a question, which tool is most precise? Well, when we have precision is how many decimal places you can go out. So the burette can go out 2 pretty reliably, and the graduated cylinders can go out 1 decimal place. So which one's more precise?
Mm. The second one?
Well, it would be really a tie between the second one and the third one, but the burette is very easy to read out the 2 decimal places, whereas the second one's a little iffy. But, whatever you decide, you need to say, it says, how do you know? Just don't say, burette. Well, you got to write down how do you know? And then finally, we got C density of antifreeze. And so it says weigh. Now this is part C. This is all being added in here. Part B, next one up, keep going. Might be page 3. It might be page 4 by the time you get down there. That's okay. What is the dry flask weight? Well, it's 88.052 grams. We need the dry flask. Why do we need? I'm just going to skip ahead to part 3 here. Let's do text. So this would be part C. And because I have some important points I want to make here. First off, this is part 3. First off, the container is never part of the measurement. You always subtract off the container. Always subtract the empty. Now, why would we want to do that? Well, we are measuring the container, empty container. We are measuring the density of the antifreeze, not the density of the container. Okay, so we need that empty weight. Now, when we add, there it is, still 88.052. And then we're going to add 10.00 milliliters. This is another important point here. And it is the volume. Let's see, I was going to use a text because it's a little bit neater. The volume is 10.00 milliliters, which is how many sig figs? Well, trailing zeros are not significant unless you have a decimal. So actually, this is 4 SF. Not 10 milliliters, because that would be, how many SF would be 10 milliliters? Well, if you assume that 0 is measured,
Mm-hmm.
it is what? It's 2.
12. Oh, yeah, 2.
Yeah, it's 2. So we say 2 SF. We're trying to be We're trying to be precise. In other words, how many decimal places can we go out? So we want to be able to go out at least 4. All right, and so when we take a look at this lab, we got 3 decimal places here. I mean, we got a bunch of decimals. Okay, so this is 5SF. By the time now, this is after you add the antifreeze. Look what happened to the weight. It went up. What did it go up by? The antifreeze. You subtract off the 98 and some change from the 98, 99, and that gives you the grams of antifreeze.
Mm-hmm.
And here's your second measurement. Subtract off your empty, that's your grams of antifreeze. Okay, there should be 3 of them. Yep, here you go. 98.627. There's my empty, 88.052. So you're subtracting off 88.052 for all 3 of these measurements. Okay, so you get, and you should get about 10, let's say 11 grams or so. Now you got to remember, this is for 10 milliliters. We want to know the density is grams per 1 milliliter. Okay, so what do we need to do with that 11, let's say it's 11.2318 or whatever. I'm just making up numbers. Well, you have to divide by 10.
Mm-hmm.
And that'll give you the density of that one is 1.1238 grams per milliliter. You do that for all 3. You should not be very far off from the true density of antifreeze, which is 1 point something or another. It's in the text. Always subtract off the empty container. And so we take a look up here. We have density over volume, and you see the actual density is 1.113. If you get 11.13, it means you didn't divide by 10. If you get just 11 or just 1.1, you didn't use 4 sig figs. In other words, you did 10 milliliters instead of 10.00 milliliters, which is 4 sig figs. So your answer should be 4. So you take your experimental, that's what you measured,
Mm-hmm.
minus the actual. There it is right there. These are absolute bars, which means keep it positive, and divide by the actual, which is 1.113, and then times 100, and you're done. You got your percent error. There's your waste disposal. Significant figures, just make sure that on discussion questions you write out, you're going to say, we're going to have down here, you're going to have another page, a separate page, and it says discussion questions. Oops. Discussion. Let me make sure I'm pretty sure I'm massacring that. It is 2 S's. There we go. All right. Discussion questions. And what I want y'all to do, discussion questions. What I want y'all to do is make sure you write down the question. So, for instance, number 1 would be how many sig figs? Okay, and we look over here to the lab and it says 76.0. Okay. And so we go A, 76.0. So how many sig figs is that?
That is 3.
Yep, trailing zeros are not significant unless you have a decimal somewhere, so you write down 3 SF. All right, so what you don't want to do is just say A, 3 SF. Well, we need to see that if you look at this again, a month from now, you should be able to say, oh yeah, that was 3 sig figs. It's 76.0. And you do that for all discussion questions. Just write them out. That's all you have to do. Alrighty. And then this is mixed calculations. Once again, this is like pages 1 through 6. Show you how to do this. And also the videos. The videos that are posted also show you how to do this. Now, don't forget, let's do 2500. how to do sig, how do we do, all right, I should have, what happened to my, oh, I'm looking at the instructions, 2,500. So let's say we have, this would be 2. Let's say we have 2,500.
Mm-hmm.
And we want to write that in scientific notation with 3 sig figs. How would we go about doing it? Well, you look at it and you go, well, here's 1, 2, 3, 250 with a decimals, but you got to count back. So we say times 10. How big is this? 1, 2, 3, 10 to the third. That's your scientific notation is times 10 to the third. And then you got to go 2.50. This is 3SF here. And one of the key is decimal is always behind always behind the first number. Okay. I've seen people write out things like this, which is, let me change colors here. I've seen people do this, which is they'll give me an answer of like 248 times 10 to the 6th. Okay, how many sig figs is this? It's 3, sure enough. But where's the decimal?
Mm-hmm.
You know, it should be right there. Okay, seen people do that. So that is how you do these labs. Okay, and all of them are going to be like this. Now, I tried taking my time. I may look like I've been going really fast here, but really you just go through these guys just like that. And, you know, we can take a look at, you know, how the other labs look. So you got like, you know, let's take a look at lab 2 and you'll see that it's pretty much the same way. You know, you got a bunch of explanations. Then you got the procedure. Where'd the procedure go? Here we go. And here it is, procedure. Way to empty evaporating dish. Why in the world would we need to empty evaporating dish? Because we're not measuring the percent component of the dish.
Right.
We always got to subtract off. And it says approximately 2. What do you really need? You need the actual weight. Approximately 2 means in your lab, you just scoop in until you get like 2.004 or something along those lines. And this is your procedure, and here's your calculations. Same thing. You're following the procedure. Now, what was I going to say? Oh, yeah. Okay. So the thing is here, though, if you look, I'm going to go back on this. Once from lab 2 on, you have the experimental data. And it downloaded it. Let me go ahead and grab it off of here because we're almost done. And experimental data. Here it is. And it says mass of the evaporating dish. That's what you got. That number,
Oh, okay.
68.317, you got to subtract off everything. So you got like 1 gram and some change of the unknown mixture, which has all 3 things in it. And then after you sublime, which means the ammonium chloride comes off, that's what you have left. How do we know how much we sublimed? We take the difference because it went up the hood. And there's the evaporating dish number 2. You got another mass, watch glass and all this to subtract it off. So the data you need is right here. It's not a whole lot of data, but to be able to do the lab, let's see, go ahead and pull it up again. You're going to need that data because it's going to say, you know, what's the evaporating dish? How much of your sample? You get that by taking a difference. You should have 2 evaporating dishes, and you just read it carefully. Here's the calculations. The calculations are usually laid out in each one of these labs for like page 2 and so forth after your observations. And then you just answer the discussion questions. You see? All the labs look like that. All right, questions.
Yes, what if like what if I don't like understand something and
Wh-
how to
Which part? Just in general?
just in general, or like if there's like a calculation that I don't really know how to put together.
Well, I mean, you could just email me.
Okay.
You can either email me, or you can use that group that you're putting together.
Mm-hmm.
What's it called?
A group me?
Yeah, you can use that, or you can post. I did put I did put in here
Yes, I'm
another
still waiting
place.
for everyone to join the group me.
Yeah, I think I saw you had one join,
Mhm.
including yourself. So that makes two. I would highly encourage everyone to join her group. So that's what you do. You post it on the forum, you use your group, or you just email me and I will certainly try to walk you through everything. Okay. So there we go. I'm gonna stop sharing my screen there and I'm gonna stop recording and stop.